Callbacks. We will actually have seen this term once or twice before, the term callback. We've seen it in the documentation for some other concepts that we've already looked at, but we haven't really done a deep dive into what it means. So what is a callback? To make understanding what a callback is a bit easier to digest, I've broken this down into a few bullet points. So first of all, a callback is some executable code. For example, that could be a function that we write. And by executable, we just mean this is code that at a later point can run and do something. So we write some executable code. This code is then provided to some other code. So for example, we might pass this code in as a function argument, or we might set it as a property of another class. So we've written the code, we provided it some other code, but it doesn't run straight away. That other code is holding onto it, like a variable such as a function argument or a class property. Okay, and then the other code calls back to this original code at a given time. So for example, a user might click a button, and at that point, our code will be called back to. So some other code is holding onto our original code, like a variable, and when it wants to, it can execute, it can call that code on demand when it needs to run it, but not straight away. So what might this look like? We will do a workshop on this in just a moment to do this in practice, but a very simple example of how this could look. Let's say you have a class you've written. So here's my class here called an example. That's a normal class, and in that class is a variety of functions. So for example, I've written a function here, and I've called it some function to call back to. Okay, and I've got my curly braces and a comment to show where the code would live. So you can write a class, and in that class can be a public function, a function that somebody else can access. So that is our callback function. We write a function called some function to call back to, and that exists within a class. And then there may be some other code. So here I have a function called some other code, and that takes as a parameter the an example class. So this function expects an instance of the an example class that we've written above, and then it has that as a parameter. So this function has access to the example variable you can see. And then when this code runs, it calls example.some function to call back to. So how this might work is you would make an instance of the an example class like that, and then something might happen. There might be a key moment like a user taps a button or presses the button navigation view or rotates the phone. Some event might happen where then you run the other code and you give it the example class. So that's a very simple example of what the idea of callback code, a callback function, looks like in practice. So earlier on I mentioned that we have seen this term once or twice before, although we might not have noticed it. So indeed, where have we seen this before? Well, a very simple example would be button click listeners. So we do set on click listener. We've done this in Java and we've done it in Kotlin, which is the shorter syntax. But fundamentally, we write some code that is to be run, that is to be executed when the user clicks on the button. We provide the code for after the user has clicked. So when we're writing that code in onCreate or somewhere in our activities or fragments, well, that code doesn't run straight away. We're providing the button with a click listener. We're providing the button with that interface, and we write the code, we implement that interface, and we tell the button what code we want to run if the user presses the button. And that is a classic example of callback code. That's a callback function. The button will hold onto that code. It will hold onto that interface, our view click listener, and at a given moment, at a specific time, it will call back to that code. It will run that code that we have given. So that's a very simple and hopefully easy to understand example of writing some code that you give to some other code, our button, and that code will then be called back to at a given moment. Another example might be with our button navigation view. We have our item selected listener. Again, we write down some executable code for what should happen when the user selects an item, but that code doesn't run straight away. We give that to our button navigation view, and the button navigation view holds onto that. It holds onto the interface or that item selected listener, and when the user selects some items, then that code will be called back to. That is also a callback function. But there's an even more recent version of when we see this term callback before, and this is our activity lifecycle callbacks. If I head over the documentation now that we've already seen on the activity lifecycle, you're going to see this term over and over again. So back on the activity lifecycle documentation that we've already seen, if I do a quick search for the word callback, we can see it's all over this document, even in the first paragraph. The activity class provides a number of callbacks, and even on the right there, the lifecycle callbacks. All of those methods are called callbacks. Because even though we write the code for onCreate, onStart, onResume, etc., that code won't run immediately. In fact, onCreate will only happen when our activity is navigated to. OnStop will only happen when our app is no longer visible. So we're writing this code, but that code isn't executed immediately. It is called back to by the Android system. You may have initially thought that our main activity is the main thing. It's the top level process running when our app is running. But this isn't the case. When we open our app for the first time, the Android system is doing all sorts of things, even before main activity is even launched. It's creating a window. It's creating a space that our activity can exist. It's reserving some memory, a little special space of the processor. So if our app was to crash for any reason, it doesn't bring down the whole system. It's doing all sorts of things under the hood. So I'm doing a fictional example to show what this might look like. So the Android system, when it starts our app, might have a variable called your activity. It won't be called this, but that's the general idea. There will be an instance of main activity, but onCreate won't have happened yet. And then it will do all the work to load the window, and then at that given moment, it will call your activity.onCreate, and giving that argument the saved instance state that we've seen once or twice. It calls back to our onCreate function that we've written. It doesn't happen straight away. Then some other stuff might happen, and then the window might become visible, and at that moment, your activity.onStart will be called. And then it might set the window being marked as in the foreground. It might say, okay, this is the main thing on the screen now, and then it will call back to our onResume code. So all of the methods that we've been looking at in this section on the activity lifecycle, these are callback methods, callback functions. And this is the principle of callbacks. And as we move forward, particularly with overriding the onBack behavior when the user presses the back button, it's important that we understand this concept of writing some code, giving it some time now for the workshop on using callbacks. I've gone ahead and made a new Kotlin Scratch file, and I've renamed it callbacks. If you can go ahead and do the same, close down any other file for now, just have the Scratch file on the screen, and I'm going to go ahead and close the project pane. So I've got the full width to work with, my code editor, and the console to the right. Probably the best way that I can show you callbacks in action is for us to actually, from scratch, roll out a button click listener interface, and then actually implement that interface right out that callback code. So we're going to make a button and a click listener from scratch. So the first thing we'll need is to make our own pretend button class. So right at the top of the Scratch file, let's make a button class. So class button, just like that, and the class curly braces. Now there exists a class called button in Android, just like this, but it'll have a whole load of code, but we're going to have a very simple, stripped down version of a button. So one of the fundamental things you can do with a button is respond to it being clicked. So we'll have a function to simulate this called perform click. So if you can go ahead and write a method called perform click for our very simple button class, and later on we will simulate clicking it by calling this function. And in this we can just print a console log to confirm we're inside this method. We'll do print line, and we'll just say in the button's perform click function. And underneath the class curly braces, we'll go ahead and make a new button. So the value my button, we'll make that equal to a new button instance, like that. And we can go ahead and do my button.perform click and just confirm that we see the perform click code. And we do line 11 in the button's perform click function. So thinking back to our buttons in Android, what do we have? Well, we have a method called button.setOnClickListener. And if you can remember, it accepts an instance of an interface called view.onClickListener. So in order for us to simulate our new callback function and our new callback code, we're going to have to make an interface very similar to that. So underneath the perform click method call, let's now make a new interface. So this is an interface, and we can call this an onClickListener. And we'll do the curly braces, and we'll define the one simple callback method. This is the method that's called back to when the button is clicked. So function, and we'll just say onClick, just like that. And I'll have no parameters for this version, a very, very simple click listener method. So far this is actually quite similar to the code that actually exists in Android. There is a class called button that actually does have a method called perform click to simulate clicks, and there's also an interface called onClick listener. The real onClick listener onClick method has a view argument like that, but we're going to ignore that and just have an onClick method with no parameters like that. So now that we have our onClick interface, it could be possible to set this on the button. So how could we go about giving the button code, this other code, an onClick listener to hold on to? Well, the first thing we need to do is have a click listener as a property on the button class. So at the very top of the button class above the method, let's have a variable, not a value, and we'll call it the click listener, and we'll make this of type onClickListener. And make sure to do the interface that's within our callbacks class. Don't choose the actual view to onClickListener or any other one. We want to do our own custom one that we've just made. And for me, it's here at the top with the word callbacks in brackets. So we're going to choose our new onClickListener interface. And we're going to make this nullable. So it's possible to have a button with no click listener set. So we'll make it nullable and we will default it to null. So now we have the class property. We have the ability to pass a click listener to the button. So at this point, we should probably make a couple of notes to explain what's going on. So above this click listener property, we'll say a common way to handle callback code, and I'll do a new line, is to set a property or a variable on another class. So now what we'll do is in the perform click method, underneath our little print line, we will actually perform the callback. So we'll do click listener, and we'll do a full stop and say on click. Now we're getting a warning because click listener could be null, so we'll simply do a safe call, a question mark. So if there's no click listener set, that's absolutely fine, I'll just ignore that. So let's put a comment above this line where we do the callback, and then we'll say, this is where the callback happens. When the button is clicked, we attempt to run the onClick method, and do a new line of the onClick listener interface, if one has been set. I'll put that in brackets. They may not have set one. It would be best practice to make the actual variable property be private. And so then there's one final thing we need for a button, and that's the opportunity to actually set this listener, set the callback class, or interface rather. So we'll do one final method, function, and we'll call it, exactly like a real button in Android, set onClick listener, just like that. And we'll give it one parameter, and that is the actual listener, onClick listener, being sure to select our callbacks one that we've just made. We'll do the function brackets, and then this is where we'll set it. So click listener, our class property click listener equals the listener in the parameter of this function. So one final comment there, we could say, this is where we provide the other code with our callback code. The callback exists within an interface. This is where we give the interface to our button class. So if you scroll down and actually set an interface and implement the onClick method, well, hopefully some of this code will look very, very similar to all those times we've set onClick listeners before. So scroll to the very bottom, we'll leave the button and perform click without the interface being set. You can see we still just have in the button perform click function line 26. Then we define the interface. Then underneath the interface, let's now set an interface. So we'll do my button dot set onClick listener. And this takes an instance of our interface. Now you might hope to be able to just do the class curly braces like this. Unfortunately, it's not quite as simple as that. The lambda style, where we just get this shorthand, it actually only exists for interfaces defined in Java, believe it or not. There's a slightly more complicated thing we would need to do to be able to use the lambda. But that's actually okay. For our understanding, it will look better to see what's really going on. So do the normal curly braces. If you think back to when we implemented interfaces a couple of sections ago, there's actually a way of doing an anonymous class, an anonymous interface implementation. I wonder if you can remember what the key word is to make an unnamed instance of the interface, an unnamed object of that interface. Well, just giving you a clue there, the word we would use is the word object. And when I type it, you can see that anonymous class thing. This is a recap from something quite a few tutorials ago now. So we type the word object, just do the top one for now, then a colon. So this object, this unnamed class, extends, and then onClick listener. Our onClick listener, the one defined just above. We don't need the new class braces like that, but we do need the curly braces. And then in the space between the two curly braces is where we would implement the method. You can click here and use the error, Alt Enter Option Enter, implement members. You can do it that way, or you can simply just start typing onClick in here, and that's the one I will do. And then this is our callback code. This is the onClick function of our interface, and this is where we can define what should happen when the user performs a click. So to show this in action, we'll simply do another print line, and then we'll say, now we are in the callback code, exclamation mark, exclamation mark. So if we scroll back to the button class to see the flow of this, so we can make a new button. The button class or object can have a property called click listener, although it could be null. That's the way that we can hold on to the callback code without actually running it immediately. We hold on to it in the form of a property, like this. We set it in the set onClick listener method. We make this public, so other places can set the onClick listener. And then you pass it in as an argument. And we set the property there. So now the button class, the button object, has a reference to the onClick listener. We only actually call back to the onClick method at a certain moment, here, when the user performs a click. So we should see the print line for the in the button's perform click function. And once we set the interface, if click listener is not null, then we perform the onClick code. And that is the callback. This is the moment when we're calling back the code. It's not here where we set the onClick listener. That's just where we give the other class the code. It's at this point later on when we call that interface's method. So let's go ahead now. Underneath this part where we set the onClick listener and do the final piece of the puzzle, we will now do perform click again. So my button to perform click. Wait for that to update. If I scroll to the very bottom, line 42, I can see a grey thing here because there's more than one line. And when I expand it in the button's perform click function, now we're in the callback code. So this here from line 34, this my button dot set onClick listener, and then an anonymous class, this object syntax. This is actually very, very similar to what we've been doing all along with real buttons and real click listeners in our Android projects. But now we understand that all it is some callback code. We give it to the button in the form of an interface, the method, and that interface is held onto by the button as a property. It keeps hold of it, ready to call this method, and then when the button is clicked, it has the interface, so it can call the interface's onClick method. Just like that. So congratulations, you rolled out your own button from scratch, your own onClick listener from scratch, there, and then you've implemented the interface, and in doing so, you've given it the callback code there. And that is pretty much the concept of callbacks. The ability to write some code, give it to some other code, and then the other code can call back to it at a later point. Let's put all this into practice now by heading back to our project, and then looking at how we can take the point where the user presses the back button and provide our own on-back button callback code. So we're now well equipped with the knowledge and understanding of how callbacks work, and we can use this now. We can now hook into a callback for when the user presses the back button that exists within Android. If you remember, a few tutorials ago, just before we did our programming concept on callbacks, we got to the point where we were saving the user's message in our onDestroy method. We were taking whatever they had written in the edit text message you can see here, and we were saving that to a file in its convenient little one-liner you see there. However, we did discuss that using onDestroy like this for, say, important data isn't the most reliable thing. onDestroy is not always guaranteed to happen, and really we should be taking extra care when it comes to protecting the user's data, especially if they do something like leave the app accidentally by pressing the exit button or by pressing the back button by mistake. We discussed that a better way, rather than attempting to do cleanup and destroy, would be to somehow intercept the user before they leave the app, ask them if they're sure they actually want to leave the app, and try and intercept them from leaving it in the first place. And the way we can do this is by capturing the moment when they press the back button. So to understand how we might go about doing this, let's head over to a browser and see Android's guidance on using the back button and how to capture that moment. So I have my search box ready, and once again I'm going to show you the type of search that you could do if you were to find some of these answers yourself. I'll do something very generic like Android back button, simple as that. And this time at the top I don't get the Android developer guide, so I'm going to scroll down a little while until I can find developer.android. And for me here it was a few down, so I'm always going to developer.android.com, ignore anything else like support.google. So developer.android.com, and here we go, provide custom back navigation. This is exactly what we want to do. And in the official documentation, we get an introductory paragraph explaining like, well, I'm going to go to the second one. So if to handle back button events, we recommend using the on back press callback instead. Okay, and this on back press callback exists in this section here. You can see in the second paragraph. But this way is slightly more complex. So we'll start with a real simple way, and we can simply intercept the on back pressed method. And this works very similar to our lifecycle callbacks, where we have on create, on resume, on start. We can simply override on back pressed, and this will give us the chance to intercept when the user presses the back button. So let's go back to the Android Studio now and do exactly this. So for now, I'm going to go ahead and comment out the on destroy method. Command/Control/, and underneath it I'm going to type on back pressed, and you can see that autocomplete is suggesting I override the method. So if you go ahead and override this, this method will be called, or rather it will be called back to, anytime the user presses on back within our activity. And like with most of our lifecycle callback methods, when you override the method, the first thing that is auto-populated is the super.onBackPressed. Remember, our activity extends from app.compat activity, and all of these lifecycle methods and the onBackPressed callback, well, they exist within the parent activity, app.compat activity. So the default thing that happens when you override a function is it will call the function that exists in the parent and run that code first. So to show that this is actually working, that we are indeed intercepting the user pressing the back button, we can show a simple toast. So we can go ahead and do toast.makeText, and the context can be this for this activity, and we'll say back button pressed, and we'll do toast.length long, and do .show. So we'll go ahead and run this now, leaving the super.onBackPressed call in, and see what happens. So I'm not going to bother typing anything in, but I'm going to press the back button on the phone. Okay, and the app still exited. But if you notice, when I press the back button, we do get the toast, back button pressed, but unfortunately the app disappears in the background. So let's have a think as to why that might be happening. Well, because we left the super.onBackPress method call in, that's going to go ahead and run the code in the app.compat activity, the parent class. If you were to command click into this or control click, well, you're going to get the parent code with a backpress dispatcher on backpress, and we can command click into that. And eventually, if we go deeper and deeper into this code, the underlying code in the parent classes, well, there's going to be some code that fundamentally is going to finish our activity, as that is the default behavior. Okay? You can go ahead and close these parent classes. I just thought I'd show you how in the underlying code, when we have the super.onBackPress method or super.onCreate, lots of things will be happening under the hood. So what we can do to prevent this from happening is simply remove the call to the super method. So by deleting super.onBackPressed, that code won't run. We're overriding onBackPressed, so this code will run. And because we're not calling the super method, the default behavior, the exit activity, won't happen. So let's go ahead now. I just thought I'd show you how in the underlying code, when we have these super, as that is the default behavior. Okay? You can go ahead and close these parent. I just thought I'd show you how in the underlying code, when we have these super.onBackPress method or super.onCreate, lots of things will be happening under the hood. So what we can do to prevent this from happening is simply remove the call to the super method. So by deleting super.onBackPressed, that code won't run. We're overriding onBackPressed, so this code will run. And because we're not calling the super method, the default behavior, the exit activity, won't happen. So let's go ahead now and run this. So now when I press the back button press, we see the toast, and this time the app does not exit. So we've been able to prevent the user from backing out of the app accidentally, which is absolutely fantastic.